Hey everybody, hope you're doing well still. Hope you're enjoying some of the nice spring and summery weather. Hope everybody's healthy, and hope you're all still kind of listening here and doing some stuff. I think that's great. I'm proud of everybody that has continued on and done some work. I think you're gonna be happy you did when it comes to next year, and just in general finishing out the year. Um, This probably will be the last section of new material. I think this should do it if I have it planned out all right. If not, we'll see what else we can do. But this last section will be broken up into two videos. Not too long a one, especially the first one. The second one maybe a little bit longer. I think we'll see. I forget where I have this broken up to. But anyway, so techniques for evaluating limits. So we learned last time that the first thing you want to do is go ahead and just do direct substitution and see if that works for your limit. And if it doesn't, then we have a problem. Then we're going to have to use a graphing calculator, look at the graph, look at the table, make a chart, whatever at that point. Not the best kind of technique to use, okay? So for example, if I look at these two, if I were to do direct substitution on this one, you'll notice I get 2 squared minus 4 over 2 minus 2, which gives me 0 over 0. We'll come back to that 0 over 0 later. Here I get 2 plus 2, and that's 4. So I know the limit of that is definitely 4. Okay? So that does work out. So for this one, I guess we'll have to look at the table in terms of figuring that out on the graphing calculator. So we could go to the graphing calculator here. We could type in. I didn't type this one in ahead of time because it's not that hard a one. Let's go down over parentheses x squared minus 4 in parentheses divided by x minus parentheses x minus 2 in parentheses. Okay, again, we go to the table. Probably my table set is already good. Yeah, it is. And what do we notice here? Well, we can see that it's going here down towards 4, and as we go this way, we're going towards 4 as well. So we notice that the answer here is 4. Get the same answer. Well, they got to be connected somehow. Well, a couple ways they're connected. First off, if we look at the graphs, and we could look at them on the graphing calculator, but it really wouldn't help me much here on this one. There's actually an open circle here. And this graph looks like this. Okay? Whereas this graph, mx plus b, I'm going to put a point there. And, oops, no, over here. We have a y-intercept at 2 and a slope of up 1 over 1. Notice the graphs look almost the same. And what we're talking about is the limit as x approaches 2, right? Those little guys I like to put on there. I'm going to go armless, guys. I know it's kind of creepy. And here's that point. You know, they're both going towards the same point. Because remember, a limit's about what am I approaching? They're both approaching 4. Okay? And so they're actually the same here. So the key is this, all right? Back up. What does all this mean? Here's the key. Because we got 0 over 0, that tells me something. And it goes back to something we did a long time ago, and it's for rational functions. And what that tells me is I can factor the top and the bottom, or just maybe the top, and something is going to cancel out. And you notice that cancels out, and what I have left is x plus 2. Once that cancels out, then I can do direct substitution to get my answer. Okay? So the technique is called the dividing out technique. If a function is rational, this only works for rational right now, and when direct substitution results in 0 over 0, then there's a common factor to divide out. Okay? So you still want to do direct substitution first and see that you get 0 over 0. You want to do that kind of in your head because, you know, what if this was as x approaches 1? I can plug in 1, I'm going to get an answer because I get 4 on the bottom and I'll get some number. Okay? It's just because I get 0 over 0. So this one does give me 0 over 0. We get 9. Plus a negative 3 minus 6. That gives me 0. And on the bottom is 0. So we need to factor x plus 3, x minus 2 over x plus 3. Here's the other thing. Helps you with factoring. If I get 0 over 0, I know there has to be a factor of x plus 3 on top. These cancel, and then this problem becomes the limit as x approaches negative 3 of x minus 2. Oops. So now I can just do direct substitution. Negative 3 minus 2, and my limit is negative 5. Okay? So, you see how that one works there. I'm just looking at my notes and I noticed I had a slight error. All right. So, goal here, you're going to cancel out a common factor and then just do direct substitution. All right. So these problems are pretty simple. All right. So here, again, what do I start off with? I kind of in my head, I plug in 2, I get a 0 on the bottom. We want to make sure we get a 0 on the top as well. So 2 squared plus 2 times 2. That's 2 squared is 4 plus 4 minus 8. That gives me 0 as well. So we get 0 over 0. All right. And so that tells me that there is something common. So I can go ahead and factor. I know there's an x minus 2 factor. I just have to figure out the other one. That one's got to be x plus 4 if you factor it. Cancel. And this is the limit. Oops, why am I putting a line there? The limit as x approaches 2 of x plus 4. Plug it in, 2 plus 4, and the answer is 6. Now, I want to go back a second. Let's slightly change this. I'm going to change something here. I'm going to say the limit as x approaches 2. I'm going to have an x minus 2 on the bottom, and I'm going to already factor it. And on top, no, I won't factor it. Let's on top have x squared plus 3x plus 2. All right, so let's plug in a 2. So we do get a 0 on the bottom. And on top, I'm going to get 4 plus 6 plus 2. So it's going to give me 12 over 0. So what's that mean since I got 12 over 0? Well, it means that I can't, there's no common factor. I'm not going to divide it out to do direct substitution and solve. But it also tells me something. It tells me that what's happening here is an asymptote. See, what's happening up above here in this problem is that at x equals 2 is a hole. There's a hole in the graph here at 2, comma, that limit, 6. I know there's a hole there. Whereas here, there's no hole in this graph. What is there instead? Vertical asymptote. So, what occurs at vertical asymptotes limits? It does not exist. So, you don't go and grab a graphing calculator here. If you plug in and you get something like 12 over 0 or a number over 0, that means it does not exist. If you get 0 over 0, which we did here, then it can be factored, canceled, and solved. All right? Okay, so that's the first dividing out technique. Easy one, something we've already done before, right? Okay, I'm going to skip that problem. And the next one is the rationalizing technique. It's similar in the sense that it is a rational function. And when you plug in, you're going to get 0 over 0. To be honest, I'm not going to fake you out on these ones. And they're all going to be kind of in the same vein. The algebra on this is a little trickier. Some of you aren't going to like necessarily because it deals with rationalizing and conjugates and things. So if you get a 0, 0, then you have to rationalize either the numerator or the denominator. The other thing that's weird about this is we're used to, hey, square roots are on the top. That's fine. But we're actually going to move them. You'll see what I mean here. So let's first plug in. So if I plug in, I'm going to get 0 plus 2 minus root 2 over 0. Well, this is going to give me a root 2 minus root 2. Well, that's 0 over 0. Okay, good. So you can see that we're going to get that. I'm going to erase that because I want to use the space here. So now we have to rationalize this. What does that mean? Well, I'm going to take this function and we're going to get rid of the square root in the top. And again, these problems are fixed. So we're going to multiply by the conjugate top and bottom of what's in the top. So when I say the conjugate, this is going to stay the same plus square root of 2. And then you have to do the same thing in the bottom. Okay? Now the bottom's easy. Don't actually distribute it because we're hoping something will happen. It's the top that's a little trickier. Now, It's a conjugate, right? So what we technically have to do is FOIL it out. First times first, then outside times outside, then inside times inside. I want to talk about outside and inside. Notice you're going to have a root 2 times the square root of x plus 2, and then negative root 2 times the square root of x plus 2. They're going to cancel. So all we got to do is the first and the last. So this problem's not too bad. So square root of x plus 2 times square root of x plus 2 just gives me an x plus 2. It's going to always be minus, because you're going to take minus root 2 times a positive root 2. Well, that's negative square root of 4, which is just 2. We got to do a little simplifying. 2's cancel, and x over, again, don't distribute that in the bottom. Hopefully you see why. X's cancel. So then, what do we get? 1 over this. Okay, what we've done is we've manipulated this function. So now what I want to do is the limit as x approaches 0 of 1 over x plus 2 square root of x plus 2 plus square root of 2. Now we do direct substitution, because we're not going to get a 0 on the top. We get the square root of 2 plus the square root of 2 then, right? Because 0 plus 2 is 2. Now this one's a little more involved in terms of simplifying. Some of the others are easier. I get 2 square root of 2, because a root 2 plus root 2 is 2 of them. We should rationalize that again. Don't leave that radical there. We get root 2. This gives me 2, and the other 2 is 4. So there's my answer. Okay? It's a little tricky. All right, so we're going to do a couple more problems before we kind of end this one. All right, let's see if we can do the plugging into the 0 first, kind of in our head. I plug in 0, I get square root of 9. And I get 0 on the bottom. Well, the square root of 9 is 3. So 3 minus 3 gives me 0 over 0. So we're going to take this function, multiply top and bottom by the conjugate. So the conjugate here would be plus 3. Okay. All right, so then we multiply. Bottom, we leave alone, don't distribute, because we're hoping that x is going to cancel. The top, we just have to do, since it's a conjugate, the first term. So the square root of x plus 9 times the square root of x plus 9 is just x plus 9. Because remember, when you take a square root times itself, you just get that number back. Negative 3 times a positive 3 does give me a minus 9. Sometimes I get people give me 3 there. There's no square root. 9's cancel, right? What else is going to cancel? The x's. So that this becomes the limit as x approaches 0 of 1 over square root of x plus 9 plus 3. Okay? So if I plug in then, I get 1. We get the square root of 9 plus 3. Well, the square root of 9 is a 3, plus another 3 is 6, so we get 1/6. The limit of that is 1/6. Okay? All right. And then the last one. Maybe you want to try this one yourself. So you might want to pause it and attempt it. All right, so if we come back to this, this is what hopefully you did. Times the conjugate. Again, on the bottom, leave alone, don't distribute. Top, multiply the first terms, you get an x plus 1. Minus 1 times 1 is 1. Cancel, cancel, x's cancel, so that I'm finding the limit as x approaches 0 of 1 over square root of x plus 1 plus another 1. Plug in now. What do we get here? I'm going to actually take a little step here. You get 0 plus 1 is 1 plus 1. Square root of 1 is just 1. Sometimes we forget that. So 1 plus 1 is 2, so my limit is going to be 1/2. Okay, hopefully that makes sense. I'm going to give you a few of those to try out. Not too many in this section. You know, the first part, you kind of already know how to do that. This one, the algebra, a little bit trickier, and there's not a bunch of the problems to do. Okay.